In first part first of the same topic, factorization using identities, we did discuss some identities, and we saw that how those identities help us in factorizing the given algebraic expressions. Right. In this part of the same topic, factorization using identities, okay, so we will talk about another this identity that also help us in some different kinds of algebraic expressions. But before that, I have an example for you. The example is m raised to power 4 minus 256. We have to this find the factors of this given expression. Okay, so we can put it like this. So you can see that this m raised to power 4, this m raised to power 4 minus 256, this m raised to power 4, it can be put like this: m raised to power 2, 4 raised to power 2, that means m 2 into 2, that is equal to 4, and 256 is the perfect square of 16, so 16 square. Now here, using the identity third, using this identity, using identity a square minus b square is equal to a plus b times a minus b. So in this expression here, a is equal to m square and b is equal to 60, right? So therefore m raised to power 4 minus 256, it can be put like this: m square whole square minus 16 whole square, which is equal to, so that is this part. Okay, here is this part: a square minus b square, a square minus b square. Now this will be equal to the right hand side. A means m square, plus b means plus 16, then m square minus 16. Right. Okay. Now this can be further, okay, reduced. So it is further reducible. Okay, m square plus 4 square, right, 4 square times m square minus 4 square, right? Now this m square plus 4 square, okay, there is no such identity with the help of which we can reduce this, so let's keep it as such. But here we can use the same identity. Okay, using this identity again, we can say that this will be equal to m square plus 4 4s are 16, because this is not okay. This cannot be reduced further, so let's put the 16 value back. 4 4s are 16. Now here m square minus 4 square. Here this a is equal to m, only m, okay, because this is m square, only m, and b is equal to 4. A square minus b square means this part, it will be equal to the RHS. Okay, so now this will be put like this: a plus b is m plus 4 into m minus 4. Right. So these three are the factors of the expression in the question. Right. Okay. Now here is another expression: x plus a times x plus b is equal to x square plus a plus b times x plus ab. Okay, this identity will help us in solving some different kind of algebraic expressions. Okay, I will put down some examples wherein you can find that none of these identities discussed so far can be applied. So for example, this example x square plus 5x plus 6. See, this is an algebraic expression and we have to factorize this. See, okay, this is a perfect square. X square is a perfect square of x, but 5, it's not a perfect square 6, it's not a perfect. So it is different kind of identity where this a minus b whole square, a plus b whole square, or either this a square minus b square, none of those identities can be applied to find the vectors of such expressions. Okay, I will put down another example. See, for example, y square minus 7y plus 12. This is another expression. Okay, here also those identities, identity first, second and third, that we discussed in the previous video lecture, those cannot be applied here. Okay, so we can see here there is not a, the case of perfect squares, so I think we can use those three identities. But these identities you can see here. Okay, we will focus on this first case. Okay, see, this x square plus 5x, okay, it seems to be equivalent to this. If we compare this expression with RHS of this identity, means this is the RHS of this identity. Okay, so x square, here is x square plus 5x, so a plus b must be equal to 5, and plus ab must be equal to 6, right? Okay, let's try to solve this, right? See, let's try to solve this solution. Okay, so you have to while solving such kind of algebraic expressions, you have to keep two things important. Okay, so you have to concentrate on this constant term. So constant term is 6. Constant term, which is the constant term in this expression, that is 6, and the coefficient of x, not x square, coefficient of x here it is 5. Now we know that AB is equal to 6. Okay, here AB is equal to 6. So this A, we have to find the values of this A and B. Okay, so since A into B is equal to 6, so this A and B must be the factors of 6, right? So factors of 6 are 1 into 6, so 1 is the factor of 6, 6 ones are 6, 6 is the factor of this 6, 2 into 3, 2 is the factor of 6, 2 3s are 6, 3 2s are 6. Okay, now these two are the factors of, say for example, let's take these two factors, 1 and 6. Okay, say for example, A is equal to 1, then B is equal to 6, 6 ones are 6, right? Okay, but here is another thing, A plus B here is equal to, that must be equal to 5, right? Now adding these to A, 1 plus 6 is equal to 7. So means that these two factors, okay, so you cannot factorize this 6 by using these two factors. So you have to find out some different factors so that their multiplication will be equal to 6 and their addition or subtraction will be equal to 5. So I think this is the right choice, this 2 into 3. If A is equal to 2 and B is equal to 3, then A into B is equal to 2 into 3, that is equal to 6. A plus B is equal to 2 plus 3, that is equal to 5, right? Okay, now putting these values here, so we can say that x square plus 5x plus 6 is equal to x square. Okay, then 2 plus, instead of this 5x, we have to break this into these two factors of 6, we can write 2x plus 3x. 2x plus 3x is equal to plus 5x. Okay, so we have to keep in mind the sign also, right? Plus 2x plus 3x is equal to plus 5x, then plus 6, right? 2 into 3, 2 into 3, or simply 6, right? Then you can do one thing. Okay, then now let's try to group these factors. Okay, let's try making this one group, this another group. Okay, so what's the common here? Okay, so you can see this is 3x plus 3x. okay, I have made group out of these. Okay, you can put this like this, x into x plus 2 into x, right? Okay, then plus 3 into x plus 2 into 3, right? Okay, then see here is x plus 2x. So these two terms, 2 into x and x into x is common, right? So x is the same factor. We can take this x out. X is a common factor here. If we take x common, then here remains only x plus here only 2, right? Then here you can see 3 is the common factor, right? 3 is the common factor. Now we can put it like this, 3 into x plus 2. Now okay, so it will be equal to, this will be equal to, see now this x plus 2 and x plus 2, okay, they are the common factors of this and this, so we can take this as common. Okay, so when we take x plus 2 out of this x, here remains x. Okay, I have also taken this out, here it will remain. Okay, 3 will remain, right? Now these two are the factors of this x square plus 5x plus 6. Okay, in general we can say that, okay, if you witness such algebraic expressions, like algebraic expressions in one variable, so what you have to do in general, if you encounter with an expression like this, x square plus px plus q. This is a general expression of this form, okay, of the equation which we expression which we discussed a minute ago. Okay, so what you have to do in order to factorize this expression, so you have first find out constant, that's q, right? Q is constant. Now what you have to do, you have to find here the values of a and b. Okay, what we have to find values of a and b. What are a and b? A and b are factors of q such that a into b, that means ab is equal to q, and a plus b is equal to this p, this middle term. Okay, so whenever you are asked with such an algebraic expression, so first you have to find out the constant term, then you have to find the factors of this constant term, say a and b. But a and b, the values of this a and b, the values of those factors should be such that, okay, if we multiply those two factors, okay, we must get this constant. If we add or subtract, okay, okay, their value should be the middle term, that means the p. This is sometimes called as splitting of middle term. Sometimes this is also called as splitting of middle term, right? So let's take an example, another example, in order to find out how we can factorize this given expression of this type, right? So this is an example. Okay, this is an example, y square minus 7y plus 12. So here constant is 12. So constant is 12. Okay, but that plus 12. Okay, so let's try to factorize this. So 1 into 12, right? 2 into 6, 3 into 4, then 4 into 3. Okay, so we will stop right here. Okay, now so multiplying these two, 12 into it is equal to q. So that means, say for example, this is 1 into 12 is equal to 12. So right, okay, but 1 plus 12 is equal to 13. That's not equal to 7. And 1 minus 12 or 12 minus 1 is equal to, say, minus 11, or 12 minus 1 is equal to 11. Okay, so this seems not a right choice, so we can rule out these two factors. Let's talk about now, let's take these two factors into consideration. Okay, 2 into 6 is equal to 12, so multiplying these two, we will get the constant term, but adding 6 plus 2 is equal to 8, 6 minus 2 is equal to 4, or 2 minus 6 is equal to minus 4. So this choice is not right either, right? Now let's take these 3 and 4. 3 and 4 is equal to 12. Okay, if we add these, 3 plus 4 is equal to 7. So this seems to be right choice, right? But we have to also take into account this negative sign, right? So we can solve this equation like this: y square minus 7y plus 12, that is equal to y square, right, minus 7y. So 3y, 4y. Okay, we have to add these, but the sign must be minus. So minus 3y minus 4y. Okay, so that the sign is minus, okay, plus 12. Okay, so let's, okay, so factors of this is equal to y into y, right, minus 3 into y, okay, minus 2 into 2 is equal to 4 into y, then it is then a plus 2 into 2 into 3, right? Now, okay, so we can group these two and these two terms, right? Now here y is common, y here, y here. Take y is a common factor. Here will remain y minus 3. Right. Now here this is y 2 into 2. Okay. 3 minus y. Okay. Now let's take this minus out. Okay. It's minus 2 into 2. Right. So I can see that. Minus y, sorry, what's the common factor? 2, another 2, another 2. Y is not here, right? So we can say 2 into 2, that is equal to 4. Taking minus 4, and we take minus 4 as a common factor. So we are actually doing one thing. So this will be equal to y, then minus, when I take minus 4 out, it will here minus into minus is equal to plus, minus plus minus, minus 4, it will remain here minus, then minus minus plus, here it will remain 3, right? Then now these two factors, okay, they are same. Taking this as common, okay, I can write on y minus 3. Okay, when I take y minus 3 as a common factor, here it will be only y. Okay, when I take y minus 3 out, it will be only 4. Y minus 3, y minus 4, or the factors of this algebraic expression. Okay, fine. Now there are similar other examples. Okay, so we can solve all those algebraic expressions of this type using this identity by splitting middle term. Okay, in next video lecture we will be talking about division of algebraic expression. Okay, so tomorrow inshallah we will be talking about how we can divide given algebraic expressions. Okay, till then, Khuda Hafiz.